This video will discuss the basics of using the script command line in ShapeBuilder. Let's get started. The script feature in ShapeBuilder is a powerful tool that uses a command line interface to import CAD files, add shapes, modify shapes, apply loads, extract results, generate reports, and much more. While it may be more efficient to perform many of these tasks using the traditional user interface, the commands demonstrated in this video become very useful for automating common tasks using an external script file. The script tool is accessed by clicking the script button in the home ribbon. Since the input and output in the command line are always in the current unit style, the first thing we'll want to do is set the units in the program. From the command line, we can add a database shape to the sketch view using the Add Database Shape command and entering the name of the shape we want to use in quotes. We can also add any simple, rolled, or bent parametric shape from the command line. Many of the commands take a different number of parameters, and to learn more about a particular command, enter its name inside quotes into the help command. This launches the help file and takes us to that particular command so that we can see the various inputs it can receive, a description of what it does, an example of how to use it, and an explanation of the example. Let's copy the Add Rolled Channel example and paste it into the command line. Note, a semicolon can be used at the end of the command to suppress the return value. In addition to adding database and parametric shapes from the command line, we can add custom shapes to the model defined by a list of the shape's X and Y coordinates. Let's define some variables in the command line to help generate the coordinates for the custom shape. Note, when storing a value in a variable, the line must end with a semicolon. Variables circumvent the need to input the same number over and over again. While math can be performed in the command line, it is important to remember that the quotient of two integers is an integer, which may not produce the intended result. Using the defined variables, we can create two lists for the X coordinates and Y coordinates for our custom shape. For convenience, the up and down arrow keys on the keyboard can't be used to auto-populate the command line with previously entered values. Now we can use two lists in the Add Shape command to create a custom plate located at the bottom flange of our W shape. Finally, we can import shapes from a DXF or DWG file directly in the command line. The Import CAD command can take various parameters as outlined in the help file. We will use this command to import the crane rail CAD file from the desktop with ASTM A36 material. In addition to adding shapes via the command line, we can rotate shapes to a specific angle or by a specific angle, as well as move shapes to a specific location or by a specified amount. With all the shapes in the right location, we can now zero the centroid from the command line. We can set the material for a shape by entering the name of the material and the name of the shape into the command. Note, if we do not know the name of the material specifically, we can use the Pick Material command to launch the material database and choose the material directly from the list. Also, if there were shapes of various materials in the project, we could set the base material directly using the command line. With the cross-section defined and the materials set, let's switch to the analysis view. Various commands are available to load the cross-section in ShapeBuilder. Axial load, shears, moments, and torsion can be applied to the cross-section with respect to the centroid, shear center, the principal axes, the global axes, or at a custom point. Let's apply shears and moments to the cross-section at the centroid. Now with the cross-section created and the loads applied, let's use the command line to extract results. We can use the get section property command to obtain simple results like the moment of inertia, Ix, or the plastic section modulus, Zx. Also, we can extract advanced results like the torsion constant J. Note, since the advanced results depend on the finite element analysis mesh, it is important to refine the mesh until the result of interest converges. We can set the finite element mesh by entering a value between 0 and 10. The mesh refinement is exponential, where 0 is coarse and 10 is fine. Note, external scripts can be used to automatically refine the mesh for a given section property, as discussed in the external scripts training video. We can also extract the maximum and minimum values of various stress results and the warping function using the command line. Use the true Boolean value to extract the maximum result and the false value to return the minimum result. Switching to the report view, we can add the various tables and graphic views to the report directly from the command line. After we get the report set up as desired, we can then export the report to a defined location. Furthermore, we can use the append results command to export the section properties from ShapeBuilder to a text file. This command will generate a new file at a specified location or append the file if it already exists. The text file can easily be imported into an Excel spreadsheet. In addition to using the built-in commands outlined in the help file, any valid C# code can be used in the command line. To demonstrate this, let's go back to the sketch view, select all of the shapes, and then delete the selected shapes. We can then enter clear into the command line and press enter to clear the script and reset any stored variables. Now let's use some simple programming to generate a shape with geometry that would be difficult to draw manually in the program. First, we'll define a function of a polygon for y in terms of x. Note, in C# there are various methods or commands of the math class that can be used in the command line in ShapeBuilder. Next, let's create two lists to store the x and y coordinates to define our shape. Using a for loop, we will start with x equals -8, have the loop continue while x is less than or equal to +8, and increment x by 0.5. Inside the loop, we will add the x coordinates to the x coordinate list, and then we will add the y coordinates to the y coordinate list using our previously defined function of y in terms of x. Finally, we can use the add shape command to create our custom shape using the two coordinate lists. In this example, we've quickly covered the command line basics and seen how to use the various commands to add and modify shapes, apply loads, refine the mesh, extract results, and generate reports. Also, we have seen how to perform some basic programming in the command line to define a custom shape. More advanced programming can be performed in external scripts that are saved as text files and read into the program. Thanks for watching and have a great day.